rotating, zooming, panning, right? If I'm a SOLIDWORKS user and I want to rotate, zoom, pan like I would in SOLIDWORKS, it's actually fairly easy. So I can go to this landing page here. So if I click on landing page, it brings up this big landing page. And if I go to optimize experience, it's going to take me to a preference page. And there are a lot of preferences in here, but don't worry, we'll get through it. If I go to the top and go to common preferences and profile, so I'm in the common preferences profile, you'll see that I can pick different options. If I pick the SOLIDWORKS one and I hit apply, what that's going to do is it's going to change the mouse zoom, pan, rotate to be just like you would have in SOLIDWORKS. The one thing that you do have to do, though, that is important, for the very first time when you change the profile, you will have to close down DELMIA and reopen it. Once you reopen it, all those settings take place and you won't have to make that change again. It will stay at SOLIDWORKS and everything will work. So if you're working in SOLIDWORKS and I'm working in DELMIA, zoom, pan, rotate, control, all that stuff works the exact same way. So that is one thing that I did forget to mention at the beginning of lesson 1. However, if you want to make that change, that's the method you go through. And then once it's set, it'll behave just like SOLIDWORKS in how it behaves in React. Today, we're going to start with lesson 1 of the DELMIA Foundations course. This is an intro to someone that maybe have familiarity with SOLIDWORKS or coming from more of the SOLIDWORKS type ecosystem. So as we go through this, please understand that DELMIA is a very high-end CAM system, so there is lots of different ways to do things. What we're going to show today is just some of the basic foundational steps that work for everyone in any of the roles that we have. But also keep in mind, as you become more advanced, there are lots of different options that you can use to streamline this workflow. This is just the most basic fundamental workflow that's out there. Keep in mind, as I program in my shop, there are lots of shortcuts and things like that that I use. So with that in mind, we're going to start, and we're going to do this in the most simple, basic way. And we're going to start by just importing a SOLIDWORKS part. But before we do that, we're starting with DELMIA shop floor machining, or the role is NSR. And from there in shop floor machining, we're going to focus on just doing a real simple mill path today. So there are ways to connect SOLIDWORKS directly to this and have revision control. You can also connect to any of the X apps or 3D Creator role as an example, and then as well as CATIA or any other CAD system that has a connection to the platform. So if we connect to the 3D Experience platform, then we can machine those products. So we're going to start today, again, the most basic way. So I have DELMIA shop floor machining up. It automatically opens with a PPR context. We'll talk about some of that stuff here in a little bit. But our first focus is to open up the part that is supplied with lesson 1. So in lesson 1, there's just a SOLIDWORKS part. So I'm going to go to my import. So we'll click on import from the plus here. And then we can search for type. As you can see, DELMIA out of the box has multiple types that you can use. We're just going to pick on the SLD PRT. You'll also notice that there's the old SOLIDWORKS format .prt if you're working on something that is a very, very old file that hasn't been converted. But we're just going to select SLD PRT, and then we're going to click our folder option here. And in the folder option, we're going to have the ability to go search. So I'm going to search in my drive, and I happen to have my training files here. So we'll go to our lessons, we'll go to lesson 1, and in our CAD file, we are looking for a part called cuts. You may recognize this file. It's the same one that we use in our SOLIDWORKS CAM Essentials book. We're keeping the consistency here just because a lot of people probably already have these files or have access to them. So from here, we're going to click open. This now brings it back to our screen. It recognizes it as an SLD PRT, where it's coming from, then we have the file name. We'll go ahead and select OK, and at this point, it's going to take that SLD PRT, upload it to the 3D Experience platform, and then you'll see it open here in a second. But what it's actually doing, to give an explanation, is it's taking that SLD PRT, it is storing it in the platform, and then it converts it to a physical product. So when we work on objects inside of the 3D Experience platform for CAM or manufacturing, we actually work on that linked copy called a physical product. And what that does is it does the same thing that we do in SOLIDWORKS CAM, where we sometimes don't want to work on the engineering data because we don't want to have access to change that engineering data. So oftentimes we'll create an assembly or we do a part in SOLIDWORKS. So we're working on that synced copy. So if engineering makes a change, then we automatically see those changes. In the 3D Experience platform, we actually work on what's called a physical product. So we have that same part linked live relationship, but we're working on that copy in manufacturing. So if engineering does make a change or make a revision, we're not working on data that's specifically on top of theirs. We're working on that synced copy. So everything stays up to date and stays connected, but we have the ability to do our things without affecting the original engineering model. So once the CAD file has come in, you can see in here we have axes, we have the imported body. If I had a coordinate system or planes, things like that, there are certain things that come in this method. However, if I want to have sketches and geometry and things like that, then I would use the connector for SOLIDWORKS, and that brings in more content from the SOLIDWORKS model. So if I had sketches or things like that I wanted to leverage in CAM, I can reuse that. So as I mentioned earlier, there's multiple ways to do things. This is just one method, and the goal here today is just to show you the workflow of how we program a part in DELMIA. As we go through the lessons, we'll show all the different ways that you can work with CAD data and some of the benefits of using the different methodologies that we have. Now, once this has come in, we now want to start programming this. So we have our object, and you can see these tabs at the top. These tabs work just like having multiple files open in SOLIDWORKS or any CAD system. So as I toggle between these different tabs at the top, I'll toggle between, an example would be like in SOLIDWORKS, I have parts, assemblies, drawings open. I can toggle between those and work on different things at different times. This works very much in that same way. So we have our PPR context, we'll come back to here in a little bit, and then we have the actual file that we're working with. So when we start working in the CAM system, what we do is you think of the CAM component as a bunch of systems coming together or a bunch of accessories, right? If we think about how we machine in the real world, we have tooling, we have vices or accessories that go on the table to make the part happen. We actually have the machine, we put all those together, and a lot of times in our head, we try to keep track of all that, right? But the problem with keeping track of that all in their head is it exists only in my head, maybe not everyone else's. So when we start programming in our DELMIA machining apps, what we do is we actually create or capture all those virtual elements and put them together in one container. And that container is known as the PPR context. So as we start programming this, you'll see me going in and grabbing some of these other things. And what it's really for is it's to take what's in my head, capture it virtually, because down the road, all those virtual things I can then leverage for scheduling, estimating, resource allocation. There's a whole bigger thing that goes into it. So not to scare anyone off, but just keep in mind as we work through this process, we're truly creating a virtual environment of things that today, a lot of us, myself included in my shop, I just do in my head. Well, having it in my head does not communicate very well to other people if I were to get sick or be out of the office for a day. So once we have this part added to our DELMIA application, our DELMIA instance, what we're going to do now is we're actually going to put this part into my PPR. As I mentioned, that PPR is the container for everything, right? So I have this part I want to machine. I'm going to put it into a PPR. Then I'm going to add my stock. I'm going to add my machine. I'm going to add my tooling. And then from there, I can do my programming, just like we do every day, right? And you'll notice a lot of similarities to SOLIDWORKS CAM as well. We define the machine, we define the stock, we have a tool crib, and then we start programming. Very much the same thing. The only difference with DELMIA is the fact that instead of just calculating it all behind the scenes, I can load in a real machine. I can load in accessories. I can create a better experience for that virtual twin. And it does come down to kinematics and things like that. Again, we'll talk about that later. So there are multiple ways to start out from here. what we're going to do today is we're going to start out with probably one of the more simplistic methods. And what that is I'm going to have my cuts part open. I'm going to go to my compass. And in my compass, I'm just going to pick my shop floor machining app again. Now I have performance feedback turned on, so I get this message. You may not have that. It depends upon if your administrator has performance feedback turned on or not. But if I have this part open and I click the compass and click on the app again, what it does is it automatically creates a PPR context, creates a manufacturing cell, and then creates a container with this part in it, automatically loads it for me. If I don't want to do it that way, then I go through more steps where I would create a manufacturing cell or a PPR context, and then I go through a bunch of button clicks to actually add it. There, in the advanced settings, there is benefit to that if I'm doing very customized operations. So I know it sounds more cumbersome with more steps, but doing it this way, there are benefits for more advanced practices. If I'm just machining something quick and easy, the best way is I import the part, then I go to my compass, I click on it, it automatically creates everything for me. Okay, so I have a PPR, I have a cell, I have an assembly. We'll talk a little bit more in other lessons how all this hierarchy works together. But if you're thinking about it from a SOLIDWORKS assembly experience, this is your top level assembly, the PPR is. And then inside of that, we have sub-assemblies and we have parts, and they're all referenced together and everything keeps track of it. But the master assembly is the PPR context. We'll also talk about renaming these and things like that down the road here. So once I have the part and the manufacturing cell and my container for what I'm going to machine, my next step is I'm going to use the wizard to walk me through what's left to program the part. So over here on the right, there are different things we can add. I have mine. I have a few things turned on. Again, we'll talk about that here in a little bit. But if I go to my question mark at the top, there is a machining wizard here. There's also a landing page, and there's some other things you can use for training, like the companion and stuff like that. But we're going to open up the machining wizard. And once this is open, what you'll notice is there's a series of check marks. Now, if it happens to want to hide over here on the right, if I hit this fly out and I hit the push pin, just like I do in SOLIDWORKS, then it will automatically stay open. Now, the benefit of this wizard is it sort of walks you through the process. By clicking on the compass and then going, starting the shop floor and creating this layout that we talked about before that's right here, you'll notice that the first section is checked. And that first section is putting a product inside of my PPR context. So it's dynamic. It automatically takes you to the next step. And the next step is we want to either bring in an existing machine or we want to use a generic machine. Now, one thing that's important to note is when I do generic machine, it's very much like SOLIDWORKS CAM or like other systems where when I create the generic machine, we're just sort of calculating it in the background. We know what the limits are. We know what the post processor is, but it's all things that are sort of taken for granted. When I start to do mount and import resources, that's where I can bring in real virtual machines. So if I brought in a Haas VF2 or a Tormach or a Plasma, or you pick the machine and all the kinematics are there, then I have the ability to start building up that virtual experience to where as I put my part in and I place it on the table and I create the tool paths, then everything automatically runs when I do simulation. So I can do true kinematic simulation. There are options in different levels of DELMIA to do cutter location verification or G-code. It just sort of depends on what you're going to do. But it is important to understand that there are differences on mount and import versus generic. If I'm just doing something really quick and I want to program the way that I always have, I'll just click generic. For this example today, we are going to use generic. So I'm just going to click on my generic machine button. And it's going to bring up a window to where I can, pick a post processor. I can pick the number of axes. So by default, it goes to a 3-axis machine. I can do, a 4th or 5th. In shop floor machining, you can do pre-positioning or 3+2. So I have 4th and 5th axis available, but only in the indexing standpoint. There's lots of settings in here. Again, this is a very powerful CAM system, so there's a lot of settings, some that some of you may not be used to. For example, like in SolidWorks CAM, when I start a part, there's a tool crib that's there, and it's linked to a library. I can do the same thing here if I have catalogs set up, which we'll talk about later, to where this machine now looks at a specific catalog. So if I had a certain number of tools only for that machine, I can pull from that catalog, and then it narrows down the time or options that are available as I program. If you want to do 3D cutter contact, post processors, DELMIA does come with a library of predefined post processors. These come from IMS as an example. You can also create your own. So in here, if I were looking at this list, sorry, I was looking at the words table. You can see that I have a couple machines here that were custom post processors that are run in my shop. So if I pick on that, then it'll automatically put it, and then you can output to apt or ISO and all the good settings you want to use here. As I move down, then we also have things that you can turn on and off specifically for this program as it relates to NC output. So even though I have a post processor, I now have other variables that I can control too. It's not just everything has to be done in the post processor. I can write a post processor, and then for specific programming, I can turn on and off different settings here. But that's not what we're going to cover today. So I'm just going to select OK here. Don't worry about the post processor that was selected, because we're not actually going to run this on the machine today. We're just going through the process. So once we have the machine defined, and I should mention over here, you can now see in our list, if we're treating this like a SolidWorks assembly, we have our top level assembly, then we have a sub-assembly with a cell, and then in that cell we have a machine, we have what we're going to machine, and then we have machining programs. So as we go through this wizard, all this stuff is automatically being built for us, which is pretty nice. So our next step is we have to define stock. Now, we have a part to machine, but we don't know what we want to machine it from. So we'll pick our stock command. And you have the option in the stock command to use an existing part. So if I had two parts, or I had a remnant from something that I wanted to reuse, I could do existing part, go pick that, drop it in my assembly here or my manufacturing cell, and then it'll machine the difference between the two. If I don't have existing stock, then what we're going to do is we're just going to create a new part or new component on the fly. Now, where this varies from SolidWorks CAM is in SolidWorks CAM, when we do the automatic bounding box of the stock, we're referencing that on the back end. So we know what the stock is. We create the mesh model. We're comparing the two. What we're actually doing here when I pick new part is I'm creating a brand new part, just like you would create a part in SolidWorks. So the user interface and experience is similar, but keep in mind that when we create this, we are actually creating a brand new part. So in this new part, I'm going to pick where I want it to go. So I want this to be located in this manufacturing product because I want the part to be machined and the stock to be tied together. So if I open up this object on its own, I have the part and the stock as one thing. Again, think of it as a sub-assembly with parts that are tied to it. Now, there are different options here that we can use. To keep it really simple today, we're just going to do bounding box. So once I know where it's going to be placed, I just click on the part, and it creates the same automatic bounding box that you would get in SolidWorks CAM, or even the automatic bounding box feature that's in SolidWorks if I use that. It looks at the geometry and automatically creates a bounding box around it. Now, if we were using, some of the sketches and planes and things like that, you can have the automatic bounding box auto size and do some really cool stuff. But that's for another lesson if I'm using the more advanced import tools. For today, with just a basic SolidWorks part or a basic CAD file that's imported to DELMIA, we just look at the geometry and we create a bounding box. Now, if I hit this arrow out, you can adjust the numbers. You have min, max, and then you have your deltas for the overall. But one thing that is sort of cool here too is I have the ability to drag on any of these arrows and change the size on the ruler as well. So if you wanted to just go in Z up to do a facing operation, I can just grab this top arrow here, drag it up a certain amount, it'll snap to the ruler, and then I have extra extra material in Z. So there's lots of cool things you can do here. But again, this lesson is just going through the process. So I'm just going to select OK. And I now have my stock part and I have the part that I want to machine. Both of them get put in this container under the manufacturing product. And the value of creating things like this and separating it is I can now open this up and I know what my stock is to start. I know what my part is I'm going to machine. I know the machine that I'm going to run it on. Everything that I do in my head is sort of getting tracked here. And then downstream, I can leverage this to create the bill of manufacture. I can create process planning rules. I can do all kinds of stuff to enhance the entire manufacturing process, even though I'm just doing the CAM stuff today. Now, if I don't care about that and I'm just doing the CAM stuff, this also still helps me have a virtual version of what I was thinking when I programmed the part. And all of these things can be changed. So if I wanted to go from a 3-axis machine to a 5-axis machine, I can swap these machines out and then the programs update accordingly. It makes it very, very easy as you start doing more complex stuff. So we have the machine, we have our stock, we have the part we're going to machine. Our next step is we're going to define for the system what is the part to machine, what is the stock, any Z-axis work offsets I want to do. And we do that through editing the part operation. So our next step in the wizard, we're going to click Edit Part Operation. And we'll bring this box up here. And in this box, it's interactive. So I get the ability to pick what I want to be the rough stock, what I want to be the design part. And when I do this, I want to show you something because this for some people is a little bit different than what they're used to doing. So I'm going to start by clicking on the rough stock tab right here, this sort of salmon color. I'm going to click that. And then when I pick on the part, or pick on the stock, it highlights blue, but you notice the dialog box doesn't come back. To get the dialog box to come back, you can either hit the escape key or you just double click out in the graphics area and the box comes back. Some of the dialog boxes that we have in DELMIA are dynamic like this, because if I had a very complex assembly and imagine having the machine and a 4th axis and other things in here, and then you have this dialog box, it makes it hard to select, right? So there are a fair amount of instances where what we do to make it easier for the user is we go through and we make these boxes disappear. So that way you can select what you need to select without manipulating or moving the display area. And then when you're ready to go back to it, you hit the escape key on the keyboard, or you just double click in the background window and it accepts it. Now, intentionally, I clicked the wrong one. So my stock is turned green to let me know it's there, but you notice as I look at it, it's the wrong one, right? No worries. All I have to do on any of these interactive settings, if I don't like what I selected or I just simply want to make a change, because sometimes we want to make changes, all I have to do is right click on it and say reset all selections, and it deselects everything. It goes back to that salmon color. So the dialog box that we have here is very, very interactive. It's just one of those things to remember. How do I get back to it after I've made the selection? So I reset it. I'm going to click my rough stock again. And the other thing I can do is I can actually go over to the tree on the left and I can pick the body I want from there. So if I had a really complex part and it's not always easy to select one or the other, I can pick it from the tree as well. It's really up to you on the selection. So I define my stock. My next step is I'm going to pick the part I want to machine. So again, I can pick it from the window out here. Or I can go over to my tree on my left and I can pick that. When I'm ready to go back for the next step, I just double click in the graphics area and you'll now see that I have the rough stock and I have the design part. They're both green, letting me know that the system knows now what I'm machining versus what I'm machining from. And this comes in really handy when we start talking updates and changes and things like that. Now, if I had fixtures or vices or clamps, I could do the same thing. I can pick all the fixtures and then it'll know how to avoid them automatically. So I'm doing a little bit of that upfront work to make my programming downstream easier. It also comes in handy when I do design changes, right? If I swap out the parts, then it knows exactly what the part is and the boundary is. My toolpaths update more efficiently. The last thing we can look at is if you wanted a safety plane, so all tools retract to a safety plane above. I can come in here, I can pick on the safety plane, pick the top of my part, and then if I wanted extra height above that face, I can do show height offset, and this will give me a ruler on the screen, and I can drag in real time or snap to the ruler where I want that to be. So now all my tools would retract to that safety plane if that's how I want to program it. So there's a lot of interaction that happens in these boxes. So we'll click there. We can turn off that grid. You can keep it on or off if you want. You can also click on the number. So if I wanted that to be at an even 1 inch or 25 millimeters, if I'm doing it in metric, you can just click on the number of where it's at as well. So there's lots of interaction that's happening here. The last step, which we'll talk about in a later step or later lesson, is the ability to adjust the coordinate system, put my work offset, G54 through 59, whatever. I can put all that and adjust it here. For this lesson, we're not going to worry about it. So I'm going to select OK. And now I have my stock and my part I'm going to machine defined. I have a safety plane set. So anything that I program, if I turn on, hey, go to the safety plane to retract, I know everything will retract to those safety planes and away I go. Now, the one thing we haven't talked about yet that I'm going to use here in a little bit, and I don't want to confuse anyone, is we can auto hide and show different bodies. As we look at it right now, I have my stock and it's about the same size as my part, right? So in certain instances, you know, picking edges, it's probably not always going to be the most clear, especially on a complex part. You know, if you imagine I'm doing a casting and I'm just machining the difference between a casting and putting some holes in it, you know, my stock is going to look almost identical to the part I'm machining. So to make those selections easier, once I have my stock and my part defined in the part operation, what I can do is I can turn on the action pad, and this will now allow me to dynamically hide or show different things. Because I predefined it up front, it's now just a toggle to hide stock, hide part, show part. If I had a real machine in here that was virtual, I can hide and show the machine, hide and show the fourth axis. Once those things are defined on the front end, it's now just a toggle to turn them on and off. I happen to have mine docked over here, but if you want to turn on the action pad, it's really simple. We just right click, we go to display, and in the display, there's the action pad button, and you can turn that on or off. Once it's on, it'll show up out here. You can dock it to the left, dock it to the right. If you have two monitors, you can put it all on another monitor. It's really up to you. It behaves very, very much like SOLIDWORKS. So in the action pad, you have the ability now, because we defined it in the part operation, I can hide or show stock with a button click. I can also hide or show my part with a button click. If I had the machines, it can turn it on and off. This is a really handy tool. I find myself using it quite a bit. And again, it's just right click in the graphics area, display, action pad. As we go through the lessons, there's more automation you can do, but just to give you an idea of how that behaves. So why did we do that? Well, we did it because here in a little bit, we're going to do some programming, but I'm going to toggle back to my wizard because now we're down to tooling. We have the machine, we have the stock, we have the part, we've defined what's what. So when we do the simulation, we know exactly how it's handling. Our next step is tooling. Now in tooling, if I have a tool library or a tool crib, I can just go pick and pull from those. And in a later lesson, we'll go over how to set all that stuff up. But let's say I just really want to quickly program this part. I haven't really taken the time to set up any of the automation that I have. I can create tools on the fly here. Is it the best method? I would argue if I'm programming every day, I would set up a tool catalog over time because then I don't have to go through the steps of creation. And then I can also apply automatic rules to it. So if it sees a pocket, it knows how to machine. But there are also times where I'm machining a part and I know I have to order a new tool and I don't really have it set up and I just want to get through the process quick, maybe for estimating or quoting. So to do that, we do resource creation. So over in the wizard, I'm just going to click on the resource creation button. And what it's going to do is it's going to open up a window here inside of my program. And it's going to say, okay, what type of tooling do you want to do? If I'm just doing individual tools, I can just start programming up here. But if I wanted to use an assembly and bring in a custom holder and do all that stuff, I can also create a tool assembly. You can create one with a multi-cutter. You can do probes for stylus because we can do probing in here. But again, we're on lesson 1. So we're just going to go to milling items, and we're going to go and just create a simple end mill. So I'm going to hit this drop down. I'm going to click an end mill, and it's going to automatically create a 3D model of an end mill. And then from here, I can now customize this to what I need it to be. So the first thing I'm going to do is I'm going to change the name. Because this is 3D, these objects, once created, will be stored in my common space or database. So I only have to create this one once, and I can use it wherever I want to use it. So as I'm doing this rough and dirty programming, it's not like I'm just creating an object that resides in here. I'm creating one now that can be available to be used anywhere. I can also share this with other team members. So if I had one person that was a tooling expert, they could go through and create tooling that we would all use if we wanted to. If I want to keep it to myself, I can keep it to myself. So for this lesson, I'm just going to do sample end mill. In the comment below, I may just do lesson 1. That way I know if I go search for this tool later on in time, that this was one I used for training, not one that I'm actually going to use for production. So I put in the name, I put in a description that I want, and then I can start making changes to the tool. Because this is 3D, I have the ability to treat it just like a SOLIDWORKS model. I can double click on the number and change the diameter of cut. So let's say I want to do 1/4 inch. I don't want a radius on it. I just want to cut all the way through. So we'll just set that to 0. That will make it a flat end mill. And then I could cut, or I could change these. And you'll notice that these designations here, LE, APMX, OAL, DHub, that's ISO standard terminology, because DELMIA, our NC machining apps, we support all the ISO tooling. There's actually other roles that are available that allow you to do direct import from vendors' websites that has the ISO standard tooling. So there's lots of syncing that happens here. So if you were looking at a cutter on a supplier's webpage, you would see LS or LH or LE or APMX, OAL, DHub, DC. That tells you exactly where to fill in these dimensions. But because it's a 3D model, if I rotate it around here, I'm editing it just like I would in any CAD system. One other thing we'll talk about here quick is if I click the parameters button, then I can manually do it here. There's also technology involved. So if I wanted to put in fluid speed, machining life, max life, weight, chip thickness, item count, all that stuff comes into play here. Lots of things, again, that go into that downstream. Feeds and speeds, if I knew I was only going to use this in aluminum, I could set this up for different material types. As I apply feeds and speeds to the tool, anytime I then use this tool, I can automatically just select from the drop-down menu in the operation and pick the different parameters I want to use, and it'll auto-populate. So if I knew for my company, I'm going to run this in steel, and I'm going to use it for profile contouring, and we're going to do finishing, I could add that here and then fill out all my feeds and speeds for how we're going to run it. And then anyone that uses this tool will now have the option to use those settings automatically. Do I have to? Nope, but they are there. So you can set up more of that company standard-esque workflow, and then people can just pick the drop downs. So through the terminology, there's lots of different things here. You can set it, this is going to be used in a collet. I don't know why, but we'll use it in a collet, ER32. You can add those things. And then these things also filter out. So if I start building assemblies and it sees that you're trying to put in a holder that's on a collet, it's not going to let you. So all kinds of cool things we can do here. Again, some of this is a little heavy for lesson 1, but we'll select OK. And now we have that sample end mill added. So it's added here, but it's also added to my database. So now I could pull up this sample end mill and use it in anything that I want to machine. So it's not a wasted investment. As you program, you can build out your tools, and then over time, you can add any of those tools to a catalog and build it dynamically. You don't have to lose time to do setups if you don't want to. I know in some instances, companies spend, the first 30 days just setting up everything. You are welcome to do that. But here you can also program on the fly, build out the workflow that you want to build, and then decide, as you learn, which ones you want to keep, which ones you don't want to keep. It's all right there to be reused. So with that, we have a tool. We have our part, we have our stock, we have our machine. Our next step is programming. Now, we do have feature recognition. You'll see in the wizard it's used as optional. So if I wanted to go, automatically find that pocket and reuse it, I can. But we're gonna take another approach to this. We're gonna do it more of the operational based or the manual interactive method, and we're gonna program the pocket, and then we're gonna program the profile. So we're gonna jump in our wizard down to programming, and we're actually gonna go to our prismatic section. So as I pick on the prismatic button, it's gonna automatically take me to the correct toolbar below. Now, because there's so many different machining operations, the wizard's going to point us to the right place, and then it's up to us as the programmer to pick the operation that works best for us. So with our next step, we're actually going to do our pocketing first, right? We're going to do a pocket on the inside of this. So in Prismatic Machining tab, I'm going to click on pocketing. And when I click on it, you'll notice nothing happens. There's a reason for that, and there's a method to the madness. You can create multiple manufacturing programs. You can also jump into a program at any time that may have 20 features. And so if I wanted to do a pocket, but I wanted it to be below a certain operation, we pick the pocket, then we pick where we want to place it, and then that will automatically place it in the tree. Okay, it's not everything I create is always at the bottom. I have the ability to interactively choose where I want those to be. So when I pick a pocketing operation, it wants me to do one of two things. Either pick in the tree where I want it to be located, or if I just pick on the part in the screen, it'll automatically drop it at the bottom. But again, there's a method to the madness on sometimes we don't always want things to be at the bottom. We want to come in and say, oh, I forgot to put this pocket right here. I want to rough this out before I do finishing below. I can click the command, pick where I want it to be in the tree, and that's where it'll go. I don't have to reorder all the time. I don't have to program everything and then reorder. Although we can reorder and it's super awesome. Let's be realistic. If I have a revision or a rework, it's just extra steps. So in this instance, we have no operations. So I can simply just click on the part, and then you'll see the command start to kick off. So as I select through here, one thing that is important to mention is I pick the tool type. So by default, it's going to be at a face mill because, traditionally first thing you would do is face mill. We're just going to do a straight pocket here. So I'm going to pick the end mill option, and then I'm going to pick the select in session or the select button. Looks like the arrow, cursor arrow. And from here, I can come over, I can pick my sample end mill. And then it takes me to the next step, which is pick the part you want to machine. So if I had, 20 different parts in here, I could pick what I want to machine from, right? Now, if I want to link it to my part operation, I can simply hit escape or double click, and that takes me to the window. And then I have the option to tie it to the part, directly to the part. Now, for our example, we're going to do this a little bit different. So what we're going to do is we're going to pick the part from the window. We're going to follow this workflow because, again, we're in lesson 1 here. So I'm just going to pick the part on the screen, and then I'm going to click OK. And what that's going to do is it's going to automatically add the part that I want to do. Now, if I misselected, so for example, let's say I misselected, right? I have the ability in this window to make changes at any time. The workflow just gets you used to the right selections, but I can always make changes. I'm never stuck with what I have. So for example, on the bottom here, you can see I actually have the top of my part listed as the bottom. Well, I don't want that. I want to make a change to it. So I'm simply going to just hit the eraser. It'll remove it. And then it takes me back and it says, okay, pick the bottom of the part. And then if I wanted to pick the guides or the edge that I want to machine from, it walks me through creating the entire pocketing operation. So it's step by step because I mispicked the bottom, but I also never picked what I wanted to machine. So DELMIA is helping me walk through to meet all the basic criteria to finish this pocket. I don't have to go back and forth a bunch of times. So I'm going to pick this edge for the guide, and then I'm going to use our navigate on belt of edges and create a closed contour. Once I have that, I'm going to select OK, and you'll now see all of this stuff is filled out for me. So even when we're in our operations, we're taking that wizard-like approach of we're stepping through everything. You'll also notice the tabs at the top have a green check mark. If there was something we were missing, it would have a red exclamation mark, and it would expect me to make those corrections before I actually compute the toolpath. So if I want to have starter endpoints or tops or bottoms, if I go to strategy, I have the ability to change the pocket style, how I'm going to run it, the tool diameter for step over and X and Y. Here's our Z depth. If I wanted to do finishing, I can do roughing and finishing. We combine a lot of our operations. So instead of having a roughing operation and a finishing operation, we can combine those together in one step if we want. I can copy and paste if I wanted to rename this to roughing and just do roughing and then copy and paste it and then just turn on finishing. We have full control to do that. But in a lot of instances, I want to rough this and then I want to finish it. If it's not super high tolerance, maybe I just do it all in one step, or with one cutter if I want to do. The choice is yours. We're not telling you how to program. We're just giving you the tools to make your life easier. Same with tool axis. If I had multiple axes or I had other roles from DELMIA, then I can turn on, 3 to 5. When we program in 5-axis in DELMIA, it's simply turning on a 3 to 5. I don't have to reprogram the part. I can just leave it as 3, or I can make it 5, and then just define more geometry to make it that 5-axis toolpath. Our last step is approach and retract. So you can build approach and retract or strategies for lead in, lead out, however you want. You'll notice by default it's set to approach. If I wanted to make an edit on this, I could say, I want this to be built by the user, and then I could pick a plane, or if I wanted to go back to that retract position I had in the operation, I have full control to build whatever lead in, lead out I want. Same with clearance. If I want clearance to be to that safety plane, then every time it comes up, it'll clear to the safety plane. But I have full control out however I want approach and retract to work. Maybe in the for the first couple of cuts, I just want to plunge in and take off. But as I get to the bottom, I want to do a spiral. We have the ability to change how it behaves in levels and retracts and goes between operations. We're not going to worry about that in lesson 1, but just understand we can be as simple as we want to be, or we can create as cool and custom of things that we want to have, and then we can save those just like everything else. And then our last step is feed rate. So we have, how many RPM we want to run. We can do it based on angular or linear. And then we have our actual feed rate that we want to run. Just like everything else, we can do feed rate reduction in corners, just like you would experience in SOLIDWORKS CAM. We also have our transition. So in between toolpaths or in between levels, how do I want to handle that transition? Do I want to treat it as machining? Do I want to do rapid? Do I want to do it like my approach or retract? I can set those. You have full control to customize what happens between levels or even between one operation to the next. If you're not concerned with that, we can just leave it off. Again, we're in lesson 1 here. So from this point, I can now just click the compute button. And what that's going to do is it's going to compute the toolpath and then take me to a simulation so I could look through it and see what's actually going to happen. And there's all kinds of settings you can do in here. You can do it as a solid. You can show your toolpath, but you can see that the tool is actually going to run around. We're not concerned with this that much right now, so we're just going to hit the exit button. So in the platform, when I want to exit a command or exit a feature, there's this rectangle with the up arrow. When I click that, it takes me back to my operation. We'll click OK. And you can now see that this toolpath has been calculated. If I look at it on the screen, I can now see this toolpath. There are settings we'll talk about here in a little bit for that. If you don't see the toolpath, don't worry. I'll show you how to turn that on here in a little bit. So we've created our pocket. We're going to create the outside contour now, and I'm going to do a little bit less explaining because I know that seemed like a really long process. When you're used to the software, programming this is the same as programming in any other CAM system I have ever programmed in the last 25 years. So we're going to now do a profile contour. So I'm going to click my contour. and I'm going to pick my pocket. I could pick on the part too. It'll just drop at the bottom. You can pick either way. So first thing it asks for is pick the part or pick the bottom. I misspoke. So I'm going to hit the X here. I'm going to hit my erase. I was talking and driving. So it says select the bottom. So I'm going to pick the bottom of my part. And then it asks for the guide or the edge that I want to follow because we're going around a profile. So I'm going to pick this edge. I'm going to pick these two because I have a sharp corner. If I want it to machine on the outside, I can change this blue arrow. And then I'm going to pick navigate belt of edges, and it'll automatically go around the outside of the part because I have fillets that sort of give it that direction, okay? There are all kinds of settings in here. I can close contours, I can pick lines. If I wanted to manually pick all the specific edges, I could do that. If for some reason I wanted to have a tab here, then I would pick this profile here and then tell it to come back so far, and it would just machine that side. All kinds of options in how you select the geometry. I'll select OK. These are now set the way that I want. I'm going to do my clearance for safety plane. And in this instance, I'm just going to hit OK. And I'm doing this for a reason, because as I hit OK, you'll notice that the tool path hasn't been calculated. If I click on an operation, I have the option to compute the tool path. And then from here, you can see now the tool path has been computed. So if I don't want to look at the simulation of every single tool path I run, I can just hit OK. Then when I'm ready, I can come down and compute either individual tool paths, or I can compute everything in the program all the way to the bottom. Now, getting back to being able to see these tool paths, mine is turned on to where as I hover over it, they automatically turn on. Yours by default may not. So if you want to turn that on, it's really simple. I right click and go to display. And then in here, there's an app options. And in the app options, again, this is something I have docked over here on the right. You'll see that there's all kinds of options for how everything behaves. One of them is up here at the top for machining. So if I do display of toolpath, now when I hover over these operations, the toolpath will display just like you're used to in SOLIDWORKS CAM or many other CAM systems. There's other options you can do here too, where you could, if you have intermediate stock turned on, as I hover over the operation, it will show what has actually been machined or removed, and I don't have to do that simulation. Lots of powerful tools in here. For most people though, as they program, they're used to just seeing the display of toolpath. So in your app options here, if you turn that on, then as I hover over or select each operation, I see what has been machined. So our last step, if you wanted to see it go through everything, is you can run simulation up here if you wanted to. I can compute and check toolpath. If you were doing kinematic stuff, I can click the manufacturing program and then I can hit the play button, and that'll kick off our kinematic simulation. And then in that point, I can do material removal, compare, all that good stuff. You can do those in either one, but just understand that there are two different types of simulation we do. One is the very basic, like as I look at each operation, it just does the material removal. If I click the play button in the middle of the compass, then I'm kicking off a more advanced simulation tool. It's going to catch the same things, but just keep in mind that the play up here, and we get into later lessons and we talk about, multi-axis machining or mill turn or things like that. I want to do more advanced type interrogation of how the machine and the virtual twin actually works. We're going to be using the play button. For a simple bracket like this, which is probably laser cut or machined on a mill, I can do the more basic simulation here and fully understand what's going to happen. So with that, that's our first portion. There's a couple things that I do want to talk about before we end this lesson. One is naming convention. So by default, whenever you create a new PPR or create new items, it puts a number after it. And it creates a generic placeholder because it's a database and we want to keep everything working together, right? Just like your SOLIDWORKS PDM. So if I wanted to make a change or make a name, like lesson 1 training example, so I could come back and look at it, it's actually really simple. So I can just come to my tree tab over here, I can right click on the tree or right click on the PPR context and then just go to properties. And when I look in the properties, I'm actually going to get a lot of information here. If I had revisions, descriptions, comments, creation dates, you can see that in my instance here, I have some customized stuff that's been added by the platform owner or the person that set up the platform for me. Things like BOM description, collaborative space. These things can be required. So I have to fill these out. They can also be drop-down menus, you know, version 1, version 2, version 3. Those things are all customizable in the 3D Experience platform because, again, it's a database, right? So if I look in here, let's say I do lesson 01, Mike's sample, because it's just for me, right? I just want to see it. I don't need anybody else judging my programming skills, right? If I hit apply, then that's going to make that change. Now in mine, and this is a good example, BOM description failed. So I need to put something in the BOM description. So I can put something in there, and then when I hit apply, those changes are now saved. So now if I go search for this later on, I can search for lesson 1 or Mike's sample or whatever. But once I make that change to the PPR, now when I'm ready to hit save, which is Control S, like you would in any Windows application, or I come up here and I go to save, it's now going to save all those changes that were originally created. So the name will be changed, all the objects will be updated, my stock, my part, my tools, everything will be there. Now I can start leveraging this because they're all part of my common space. And in that common space, I can share with people or I can keep them private.